Over the years, we've been bombarded with headlines and videos promising revolutionary new battery technologies that will supposedly transform the future of electric vehicles. Every few months, a new contender is hyped as the ultimate breakthrough that will crush lithium-ion batteries and make EVs cheaper than ever. And among these, sodium-ion batteries often take center stage, especially when people talk about cost. In fact, some of the claims floating around suggest sodium-ion cells are up to 90% cheaper than lithium iron phosphate batteries, or LFP for short. But here's the truth. That's just not the case. The number sounds exciting, but it's misleading. The reality, according to CATL, Elon Musk's top battery partner and the world's largest battery producer, is that sodium-ion cells can cut costs by roughly 65% compared to LFP. That's still a massive difference, but it's not 90%. The exaggerated figure you see in clickbait titles simply isn't based on facts. CATL isn't in the business of speculation. They base their numbers on real-world testing and large-scale manufacturing data. And yet, despite debunking that 90% figure, sodium-ion technology still has so many strengths that it could reshape the EV industry in the long run. What makes sodium-ion exciting isn't just the price. It's the combination of factors: the potential for much longer lifespans, stronger performance across temperature extremes, safety advantages, and the use of abundant materials that aren't concentrated in just a handful of countries. These things together are what might make sodium-ion a true disruptor. Yes, the term game changer gets thrown around way too often, but in this case, it might actually apply. So the question is, how will Elon Musk and Tesla take advantage of this? Could sodium-ion batteries be the technology that finally replaces lithium-ion once it becomes outdated? That's the big conversation worth having, because batteries are the single largest factor keeping EVs more expensive than traditional gas-powered cars today. Let's be clear. The battery pack alone accounts for 30 to 40% of the total cost of an electric car. Even though battery prices have fallen drastically over the last decade, they still average somewhere between $90 and $130 per kilowatt hour in 2025. That means for a typical EV that carries a 60 to 80 kilowatt hour pack, the cost of the battery alone runs anywhere from $5,000 to $10,000. And despite paying that much, owners still face the frustration of range loss after just a few years of use. That's because today's lithium packs, while advanced, are far from perfect. They degrade with time and can't provide the kind of decades-long durability people wish for. That's why breakthroughs in chemistry are so important. A battery that costs less while also lasting significantly longer isn't just a technical win. It's the key to unlocking true mass adoption of EVs. And this is where CATL's sodium-ion approach, branded under the name Naxtra, comes in. Unlike lithium, which relies on scarce mineral resources often controlled by just a few nations, sodium is practically everywhere. It's in the ground, it's in seawater, and yes, it's even in the salt on your kitchen table. In other words, sodium is essentially unlimited. That means no geopolitical choke points, no looming supply shortages, and no worries about monopolized markets. This makes sodium one of the most democratic elements for energy storage. But it isn't just about abundance. Let's dig into the real-world advantages that make sodium-ion technology worth paying attention to. The first thing everyone asks about is cost, because affordability drives adoption. Right now, CATL sodium-ion technology can be manufactured at around $19 per kilowatt hour. Compare that to LFP, which averages about $55 when bought in large volumes, and you start to see the significance. That's a cost cut of about 65%. CATL's long-term goal is even more ambitious. They're aiming to reach $10 per kilowatt hour. If they succeed, that price point would completely upend the economics of both transportation and renewable energy storage. Let's put this in perspective with a concrete example. A Tesla Model 3 equipped with a 60 kilowatt-hour battery pack today carries about $3,300 in battery costs, based on LFP prices. If Tesla were to switch to CATL sodium-ion pack at $19 per kilowatt-hour, that cost would drop to roughly $1,140. That's a savings of over $2,000 per vehicle. For Tesla, That could mean either boosting their profit margins or slashing sticker prices to compete directly with gasoline-powered cars. And when EVs finally undercut ICE vehicles in price while offering better long-term economics, the industry will hit the tipping point of mass adoption. This is exactly why competitors like BYD, LG Chem, and other long-established battery makers are suddenly under pressure. Their chemistries, once cutting-edge, now risk being labeled outdated. And sodium-ion isn't just cheaper, it's also more durable. That brings us to what might be its greatest strength: lifespan. CATL sodium-ion technology has been tested to endure up to 10,000 full charge cycles, while still retaining around 85% of its original capacity. To translate that into driving terms, we're talking about roughly 3.6 million miles, or close to 5.8 million kilometers. That's far beyond what any EV owner would ever need in a single vehicle. Realistically, a sodium-ion-equipped Tesla could last an entire lifetime without the battery ever needing replacement. And when the car itself finally reaches the end of its service life, the battery doesn't go to waste. It can be repurposed for stationary storage, balancing the grid with renewable power from wind or solar. That's a perfect example of circular economics, where resources don't get thrown away, but continue to deliver value in new ways. Now, let's compare that lifespan to lithium. Even the best LFP packs in production today top out around 1 million miles under ideal conditions. So sodium-ion could potentially last 3 to 6 times longer while still maintaining healthy capacity retention. That's a staggering leap in durability. One of the reasons sodium-ion packs achieve this longevity comes down to how they operate at a slightly lower voltage than lithium cells. That may sound like a minor detail, but it has a huge effect. Lower voltage means fewer side reactions inside the cell, less electrolyte breakdown, and less risk of dendrites forming. And if you know anything about lithium batteries, dendrites are a major issue. They're tiny needle-like formations that pierce through the separator and can cause short circuits, degradation, and even fires. By running at a more stable voltage, sodium-ion simply avoids a lot of these problems from the start. Safety and reliability are other big points of comparison. One of the biggest weaknesses of lithium-ion is its sensitivity to temperature. Anyone who has driven an EV in winter knows how badly cold weather affects performance. Below freezing, range and efficiency drop sharply. At the other extreme, high temperatures can make lithium batteries dangerously unstable, raising risks of fire or explosion. Sodium-ion chemistry, however, is far more tolerant. CATL reports that their cells can operate smoothly between minus 40 degrees Celsius and 70 degrees Celsius, covering practically every climate on Earth, from the icy cold of Alaska to the desert heat of Nevada. This makes sodium-ion the most temperature-resistant battery technology currently available, which is a massive advantage for both EVs and large-scale renewable energy storage in diverse environments.